Devnexus 2022. I hope you're really enjoying so far. It's the first in-person conference after so long. I'm so excited. I'm just like hugging everyone. I hope you are too, but be careful. So now today we have a topic, pattern matching for Java. And this is one of my favorite topics because this is sort of coming late to Java. So it's late to the party, but it still has got the best features and more improvements. So we should just get started really quickly and see what it is. So today's agenda, I won't spend much time, but I'll quickly glance through. We'll look at Project Amber and algebraic data types. We'll talk about what pattern matching really is and why should you really learn about it. I mean, there are all new features. Why is this important? We also want to look at instance of, switch statements, expressions. We'll end with types of pattern matching because there's a lot of terminologies going on, so I wanted to present it at the end. And then we'll see the upcoming patterns in Java as well. So just as a point to note, the upcoming patterns in Java are changing. So whatever I'll show you here might subject to change, so don't take this by heart. My introduction, I am a vice president at Morgan Stanley, which means I code, nothing else. I still write code. I'm also a Java user group leader at Garden State Java user group in New Jersey and also at JRJavaSIG, New York. I write Java-based application for almost 14 years. I love to travel, which now has started, which I'm excited about. I practice yoga and I watch cricket. Any cricket fans? So let me know. Here are my credentials, my GitHub account, my LinkedIn page. I'll post the slides on the Twitter so that you have the slides later on, so you don't need to worry about that. And you can always contact me later as well if you have any questions after like 5-6 hours, which I usually have. So let's briefly go over Project Amber because Project Amber is where the pattern matching gave birth to. So these are the status of JEPs in Project Amber. I've highlighted the ones which are related to us. So the first one came in as 394, which introduced pattern matching for instance of. Then it came with 406, which introduced the pattern matching for switch as a preview feature. Mind it, the preview features are introduced by Oracle to get feedback from users. They are not to be used in production. Don't try to use them. If you want to try them out, you have to enable them in your IDE or through the command line. So that's how you can just use it. It's good. You can use, try, give feedback back to Oracle. So that's what they are looking for. So the first algebraic data type is records. Records are immutable data classes that only require the type and the name of the fields. They cannot extend any other classes. This is because implicitly behind the scenes, record is actually extending a record class. So that's why they cannot extend any other classes. But you can implement interfaces with records as well. Records are not by default serializable. And this is from Jose. It's a design by default. There's a reason why they actually did not by default serializable so that it's safe, it's secure. It's always, when it's deserialized, you always call the constructor and you can protect your objects and classes. So the Java lang.class API has been retrofitted to support records. So for example, given a class, we can check whether it's a record or not a record using a new method, which is isRecord method. And records generate public getter methods whose name match the name of the field. So this is different from people who are using Lombok. Lombok is also kind of simplifying your classes, but it's different because with records, it's immutable. You cannot change the value, so you don't get a setter. You set your values when you create the records, and you just get the values by using the name of the field and not the getter prefix with it. I hope you can't read this. This is intentional, but this is a simple Pojo driver license class, and you have an age. Many things are coming along, a constructor, a setter, getter, toString, equals, hash code, Have you ever written everything by yourself? If yes, then you are brave. I always generate by ID. But you can see there's a lot of ceremony going on. You don't want to do all that, and that's one of the reasons a lot of people use Lombok library. But now with Java, you can use this. You can also make a little modification here. You can have your if checks if you want to create a record or not. You can throw an exception at your constructor level as well. So that's another benefit of using records. The other one is the seal type. The other algebraic data type is the seal type. So this is really interesting because it allows the author of a class or interface to control which code is responsible for implementing it. It provides a more declarative way than access modifiers to restrict the use of a superclass. What I mean by this is there have been times when you don't want your class to be extended by other classes, which is why you declare it as final, right? But at times you don't want to declare every class as final. You want to be extended, but not by everyone. You want to control that. And also there's another principle, composition over inheritance going on here. So that's where it also supports it. The third one, support future directions in pattern matching by providing foundation for exhaustive analysis of pattern. We'll see that in the last few slides. I want you to remember this because this will come in the later slides, and I'll come back to it again. So seal classes allows to have the possibility of a superclass to be widely accessible. You can access it, you can use it, but it's not widely extensible. You cannot inherit it. This is different. A simple sealed interface, a shape which permits circle and a rectangle. And I'm using record here as circle and a rectangle, which implements shape. So this is a simple sealed class type. Now we get to the real topic, which is pattern matching. And by definition from the designers, Brian Getz, this is the definition. Pattern matching is a technique that has been adopted by many different styles of programming languages going back to 1960s, so it's not new, including text-oriented languages like Snowball 4 and AWK. It also is used in functional languages like Haskell and ML, more recently extended to object-oriented languages like Scala and C# as well, actually now added to Java now. So, and this is the link where you can find this definition and more data as well. So pattern matching was introduced as a preview feature in Java 14 and then continued to be another preview feature in Java 15. This was released first time in Java 16 as a type pattern. So we'll see what type pattern is in the next slides. It's part of Project Amber. This is where it gave birth. And it works very well with algebraic data types. And you'll see why I actually showed you algebraic data types before. It works very well with functional programming. And the main meaning behind the pattern matching is that either it will match or either it will not match. And this is interesting because when you talk about pattern matching, you are looking at things in a binary way, 0, 1. Either it's true or it's false. It's nowhere in between. And you may have, you will be thinking like, this is where programming comes into picture. Any questions? Yeah, we'll let them join us. It's fine. So, okay, pattern is a combination of predicate that can be applied to a target, a set of binding variables that are extracted from a target only if predicate successfully applies to it. I know if you're confused, if you look at the boxes here, the first part is your predicate, right? You're already familiar with it. The instance of will check and come back with either true or a false. The right part is a binding variable, also known as target, and some people also call it pattern variable. So you're looking at the combination here in pattern matching. The combination of both is called a pattern. You'll say, okay, why should I learn this? Why is it important? Anyone? Like, you want to see the clean code, you want to avoid repetition, because all you're doing is comparing to a type. If your type is yes, if your predicate returns yes, you cast it to a type. It's all like going on again and again, every time. Your bugs cannot hide anymore, because if you avoid the ceremony code and you have a simple line of code, you'll see it becomes easier to find out your bugs and you'll make less mistakes. And that's what the entire project Amber is about. It has multiple features which are making developers' life easier. Did you know pattern matching existed in Java? Anyone before Java 14? It existed in different form actually. If you look at the usage of pattern matching until Java 14, if you remember, finding a string with regex used to be like this. And I always wondered when I was reading about it, why is it not like string.search? You can search or find a pattern. It had to be pattern class, which has a compile method and a matcher class. So the architects of Java actually gave you a hint that this might be coming and this might be useful. And in this case also, if you look, the matcher.find is actually a predicate. It's telling either it will match or either it will not match. So why did we need pattern matching, to be honest? What was the problematic code? Do you see the problem here? You are writing a lot of things here. If you want to use object obj and you'll test if it's an instance of integer and you want to extract the value, int value, and use the value, you have to cast it and put a lot of brackets. And this is very lazy. Me being a lazy programmer, I never liked it. I always hated it. And if you look at this one, this goes further beyond, because now if you look at the code on the right side, you have if else, if else, if else. And if you carefully look at this, all you're doing is string.format, isn't it? So you're like hiding behind your logic and you are just, adding a lot of code. Okay, instance of check, and then you cast it, and then you use format. Should I stop? Does anyone want me to stop, or is it okay? We can go ahead. Okay, we'll see. Thank you. So here we have a lot of code here, but all we are trying to do is string.format. We are trying to format a string and object. So the code, first of all, is less optimizable. If your compiler is not smart enough, you have n branches, so you have on complexity, even though your underlying problem is just O1, which is string.format. You're doing type test and casting, and you're actually hiding behind your significant business logic, which is where errors will come in, and that's why your bugs will come in. And I never liked if-else conditions too much. I always hated it. So, instance of operator. We have always seen the equals method. Every time I write it, I never write it, I'll just generate it. So the above code is doing following things. It checks whether the object O is of type point class. If the above statement is true, it converts and casts it into a point class object. It declares a new local variable, and point that local variable can be used somewhere next line. It's a lot of repetition work going on, right? Now, what happened with Java 16, the production version of instance of operator with pattern matching? The instance of operator matches the target object to the type test pattern as follows. If the obj is an instance of point, it is cast to point type class and assigned to binding variable p. The binding variable now is in scope in the true block of the if statement and not in the false block of the if statement. We'll talk about the binding variable in 1 second, so hold on. But you look at this from here to here, the code looks a bit simpler. At least I'll type it out. I won't try to generate it with ID, although I will try to generate it with ID, but this is much better, at least easy to read. So we talked about binding variables, and we are hearing this term a lot, what exactly it is. Binding variables are special case of local variables. Aside from the definition of their scope, in all other respects, binding variables are treated as local variables. They can be assigned, they can shadow a field declaration. Binding variables are subject to definite assignment. This takes one step further. The scope of binding variable is the set of places in the program where it will be definitely assigned. And this is called flow scoping. And here what it looks like. This is a weird code, by the way. The first time I saw it was really confusing to me because this is where the difference comes from local variables and binding variables. If you see the left side, you have X instance of foo f. So the f is in the topmost f. In the if block, f is in scope there and not in the else block, which is okay. That makes sort of sense to me. But if you see the not condition, your definite assignment is not going to be in the if block. So that's why the definite assignment is in the else block. So f gets the scope in the else block, not in the if block. I want you to absorb this because this is freaky. Yes. And that's why it is different. So let's continue with switch statement and expression, one of my favorites. So Java, when inherited the switch construct, it just, I think, copy-pasted from C. Traditionally, switch had a very limited usage actually, and that's why a lot of people started using if-else conditions, and then we got stuck with it. And we were like, we want to have a better switch statements, and they are actually improving switch as we go on. You could only use switch on small set of types before, numbers, strings, enums, and you can only test for exact equality against constants. And this is a code next thing from Brian Getz, but these limitations are accidents of history. We want to improve, right? One difference from statements and expressions, Java 12 introduced switch expressions, which are like any other expression. It evaluates to a single value. But the switch expression now, it looks like a perfect match for pattern matching, right? And why? We see that. What was missing from the instance of pattern matching? This. We still end up with a lot of if-else condition. We did simplify, sort of removed casting, but we are still, writing a lot of code, and this is hard to read, hard to understand. A lot of times we are just reading the code rather than writing the code, and I don't like reading this type of code. What did the enhanced switch bring? Now look at this, and let's look at this. I believe this one is much better. I hope you agree. This way, you have all the conditions clearly visible. You can see that all you're doing is string.format, and you have the default as well. This is a switch expressions, and this was introduced in Java 17 as a preview feature. So you can't use that in production, but you can try it out as well. Handling null and switch. I have written this code before because switch were never good at handling null, and you always hit null pointer exceptions. So you have to have a if condition to check a null. If it's null, you just don't want to get into switch because it will throw a null pointer exception. So now you have a switch null case label, which is very cool. I think this is where I started loving switch, because if you want to do defensive programming, which I think this is what you should do, you can easily have a null case, but you should put it on the first case label. You don't want to put it in the next ones because otherwise it's not usable. We have a guarded pattern as well. Let's say you are trying to test a pattern, triangle T, but you want to test a large triangle separately and a small triangle separately, you can divide this by using a guarded pattern. So guarded patterns are nothing else but your primary pattern, which is triangle T, and then you have a conditional expression. And actually, I just heard today from Jose that we are introducing a new keyword when instead of the ampersand, simplifying more, so that in Java 19 you can actually just write it a bit more easier. So that will get more and more better. So, but it's still yet to come, so we'll see how it is. We have a selector expression typing as well. If you look at this, you have string S as case label, color C, point P, but you can't mix the primitive type here. That will throw a compiler error. So you can't mix the primitive and object references in the same switch. The dominance of pattern labels. So if you remember the exception handling, where you had the more generic exception at the bottom of the catch clause, and then you had the more specific exceptions at the top, this is actually exactly the same. You want to have the more specific cases at the beginning, and that's why your string sh is at the top and your char sequence at the bottom. And you cannot have your string shs and your conditional expression, your guarded pattern here, because that's actually more specific. So you have to move it to the top to make it compile. That will throw an error. Your compiler will complain. Okay, now I want to wake everyone up and find the problem. Can anyone guess what's the problem with this code, both of them? Sorry? Perfect. That's perfectly right. There's no default. You want to have, so this is a switch expression. So it's actually expecting a value. You have to define a value, and your compiler will actually know that this is missing a value. So you need to add a default. What about this? You don't need a default here. Why? Because you're using with seal types. If you remember when I talked about seal classes, I said it works very well with pattern matching. This is where it all connects. Now your compiler knows what are the expected classes to be, expected implementation classes, what are the expected cases will be. So now you don't need a default here because it's exhaustive. Okay, types of pattern matching. We talked about pattern matching instance of switch expression statements as well. Just summarizing it with a type of pattern matching. The ones we talked about, primary patterns, those were type patterns, the checking that we are doing with instance of operators. We are checking the type of your pattern. The other one, I'm going to come to this, is the record pattern. It's also a different type of primary pattern. The guarded pattern I talked about, which has an ampersand. Right now, it works with ampersand, and conditional expressions you can add. And otherwise, I think it will be introduced with some simpler keywords so that you can use it with ease and not having to add a lot of code in that. Future. This is subject to change, but this is still the proposal. The next step is going to be about record patterns. So record patterns are simply also known as sometimes deconstruction patterns. Here you can see I have a record point P, an enum color, record color point, and record rectangle. And I want to print the upper left color point. So I'm deconstructing rectangle in the if statement. And if you notice, my name of the variable's color point in the deconstruction if sentence is actually different. So it can be different. You don't have to copy paste the same name of the variable. And I'm using the C method from the record, which is given to me by default field values from records. So this is much more coming from record patterns. And this is one array patterns as well. I'm sorry, I'm missing a bracket here. I just noticed. But you can also deconstruct the arrays from here. If you have an integer array and you have 3 values and you want to do some squared sum operations of all the elements, you can use this, and that will be your array patterns. Any questions? I'm at the end. Yes, please. Mm-hmm. Right. It's all backward compatible. It's still working the same way. So switch expression is not changing its existing behavior, except they have enhanced it with a null label. So if you don't use the null case label, it will throw an exception like that. But otherwise, switch is actually the same way. Oh, no. This will actually check for a case, and then it will not check all of the cases. You don't need a break here.
Can you talk about the difference between a switch statement and a switch expression? That'll help with the question.
Yeah, that's true. Thanks. So switch statements where you need actually breaks, because if you don't use the breaks here in switch statements, it will actually fall through everything. The switch expressions, they don't need the break, and that's one of the good features about using them. But thanks, Jean. Thanks for helping. Yep.